Welcome to The Explainer. In this one, we're really digging into the science of how we can give one of our most vital crops, corn, a serious head start. As agricultural researchers, we're always on the lookout for tools that could totally revolutionize how we grow the world's most important crops. So it led us to a really simple question. Can we give corn a kind of superpower right from the very beginning?
All right, so let's dive right in. First things first, we need to understand the stakes. What's really on the line in the early life of a corn plant?
You see, a strong start is, well, it's everything. For a crop like corn, the health and just the sheer vigor of that young plant is a huge predictor of its future yield. A weak seedling? It's probably never going to catch up. And that's exactly why we're always searching for that extra edge. And that search for a performance edge, it led our team to investigate a really promising organic compound, potassium fulvic acid. We'll just call it KFA for short.
So what does it look like? I mean, visually, it's just this simple, dark substance. But as our analysis showed us, its chemical makeup, well, that holds the real key to its power.
Okay, this certificate of analysis, this is where the real story is. We're looking at a potent, completely water-soluble organic fertilizer. Just look at these numbers. It's packed with over 80% organic matter, and this is the crucial part, over 50% of the key active ingredient, fulvic acid. So, right away, the key question for our research wasn't really if KFA works. We were pretty sure it did. The real question was how to make it work best. We had to find that perfect dose.
So, to find that sweet spot, we designed a really controlled experiment. You can think of it like a Goldilocks test for corn seedlings, right? We mixed up 5 different doses, everything from nothing at all to a super high concentration, just to find the one that was, well, just right.
Okay, so let's get to the results and see what our investigation actually turned up, because this is where things get really exciting.
And what we found, honestly, it was remarkable. The data pointed to one clear winner, a concentration that didn't just help a little. It completely supercharged the seedlings. And this chart just illustrates the difference brilliantly. Take a look at the bar for the 100 milligram per liter concentration, the one labeled H100. I mean, it just towers over the control group, the one that got no spray at all. That's a massive leap in net photosynthesis.
So just how much better was it? Well, that specific dose boosted the net photosynthesis rate, which is basically the plant's engine for creating energy from sunlight, by nearly 38%. I mean, that is a huge, huge leap in efficiency for a young plant. But here's the twist, and this is what's so interesting. We found that more was definitely not better. In fact, the highest concentration we tested, 500 milligrams per liter, it actually had a toxic effect. It reduced photosynthesis by over 10% compared to doing nothing at all. This just proves that finding that perfect balance is absolutely essential. So naturally, this raised our next big question. What was actually happening on a microscopic level to cause these dramatic results, both the really good ones and the really bad ones?
Well, the answer lies with something called the leaf's stomata. You can just think of these as tiny little gateways or pores on the leaf. They control how the leaf breathes in carbon dioxide and exhales water vapor.
What we found is that the optimal H100 treatment essentially told the stomata to open wide, like really wide. If you look on the left here, you'll see stomatal conductance. That's just a measure of how open they are. It shot up by over 93%. Now, this created a trade-off. It was great because it let in a flood of CO2 for photosynthesis. But on the other hand, it also caused the plant to exhale a lot more water, which actually made it less water efficient.
Okay, so that's the science at the seedling stage. But the big question, the one that really matters, is how do these early advantages translate to the real world, to the final harvest? Because a powerful start like this, it's not just some temporary boost. When you create a more robust, energy-producing seedling, you're basically setting the stage for a more productive adult plant. It's a plant that can better handle stress and, at the end of the day, produce more grain.
And this is why it all matters so much. See, our findings aren't just for seedlings in a lab. They're backed up by real-world harvest data. As you can see here, other research confirms that using compounds from the same family as KFA can boost final crop yields by almost 25%. That's a huge deal. So what this all shows is how a really precise, science-backed approach can unlock nature's hidden potential. It proves that sometimes the biggest improvements come from the smallest, most carefully measured changes.
And that just leaves us wondering, what other secrets are out there just waiting to be unlocked for smarter farming?